Hello everyone, it's August 19th. Very late now because I was trying to solve a problem, trying to optimize, and after lots of profiling and lots of reading the code, finally I kind of found the real bottleneck, right? Real bottleneck, and I was able to handle it, and by handling it, I get 40% performance boost just by refactoring, not introducing anything else, not changing much of how the code logic works, just refactoring, avoid redoing many things, just cache, and we achieve tremendous performance boost. But I am pretty sure tomorrow, actually it's already tomorrow, but in the morning, when we have the stand-up, there'll be some battle to fight, but I am ready to fight. I'm ready to fight until the end. I have until 5 p.m. today, until 5 p.m. to make a stand and hopefully get the code pushed, at least to stage. Because I'm pretty sure I'm ending everything today. If I'm gone, no one is going to touch that code. No one is going to dig into it. No one is going to advocate for this. It is all on me. If we want this 40% performance boost, it's all on me. If I'm not doing it, nobody will do it. So I'm going for it. Tomorrow I will argue with my manager, and if that doesn't work, I'm gonna skip him and put it in some channel that almost all the engineers are subscribed to, just to spread the news, just to tell them that there is a solution to alleviate the pain, at least on this specific component. And it is your choice, your guys' choice to take it or not. I mean, in a certain perspective, if they don't take it, what's the point of going back into here? I mean, I enjoy a lot working in this place, but if they don't take the advice, if they don't act on it, now what's the point, right? They I don't know. So we'll see. I'll see how it goes tomorrow. Yeah, I think 40% is big enough that it will definitely get a lot of attention, right? Get a lot of attention. It's like right now. We have a solution right now, at this moment. So I definitely think it will get attention if we spread the word. But I kind of don't want to spread the word right now. I want to go through the manager first. There are something I don't know. He knows, but depending on how he reacts, I mean, he's a very reasonable guy. I like him a lot. I think he'll understand, but I don't think he's in the position, or he is really willing to fight or to fight for this specific battle. He has his battle to fight. So this is my battle, right? And I need his help for sure. So we'll see. All right, let's get today's thing done. I think my capacity only allows me to do one, so let's just do one and then call it a day. Split array into consecutive subsequences. You're given an integer array that is sorted in non-decreasing order. So it's okay. Determine if it is possible to split nums into one or more subsequences such that both of the following conditions are true. Each subsequence is a consecutive increasing sequence. So it's not non-decreasing but increasing. All subsequences have a length of 3 or more. Return true if you can do it, false otherwise. A subsequence is, I think it's take things away, right? Yeah, the 135 is just, you cannot rearrange them, but you can just pick them out in the original sequence. So for this one, we can do 1, 2, 3, and 3, 4, 5. Perfect. We can do 1, 2, 3, 3, 4, 5, 4, 5. Oh, 1, 2, 3, 4, 5, and 3, 4, 5. Good. It is impossible because you can do 1, 2, 3, 4, 4, 5, or 1, 2, 4. Wait, you can do 1, 2, 4, and a 3, 4, 5? Wait, hold on, what's consecutive? Is exactly one more than the previous. Oh, exactly one more. Doesn't that make this thing simpler, right? Okay, exactly. We have to be exactly one larger. And we just start going. We go 1, 2, 3. Huh. So the problem is whether we take another one or not. Four, 5. You know what? What we should do is just to get the consecutive subsequences out, like all consecutive subsequences. We don't care about splitting. Just get them out, right? All the consecutive subsequences. So we can do, do a what? Do a counter. How can we get it out the most? Yeah, we should just get them out in the most efficient way and counter, right? We have a counter, and then we start going. We have a counter, and we don't want to sort again, so we go through the original. So pick 1, pick 2, and pick 3, and whenever we encounter something new, do we? No, I don't think so. What I think is we'll go through the counter, right? And every time 1 gets out and becomes 0, we just pop it. Okay, we can just pop it, and then the next one, and the next one becomes 0, we just pop it. So we just get the first sequence out, and then we go back to the front. Okay, we go back to the front, sort it again. I mean, in fact, if you use a dictionary, which right now the dictionary is guaranteed, the order is guaranteed, so we don't have to sort. We just push them in as we go through, and then we pop them out. Pop them out. Pop them out. And as you're reading things into it, right? So you get a sequence, and whenever it breaks, right? So you get a first one, perfect. Then you try to get a second one, and then it breaks. Okay. What if it breaks? What do you mean by breaks? Well, it breaks means as we go, right? And then something just one, but we have more in here. And then we create something. And we go it again and have a single one. Say if we get a sequence out, right? And we are left with something else. If we're left with 2, yeah, let's say we get a longest sequence out first, okay? And if it's possible to do this. And after we get the longest sequence out, because originally it's already sorted. I think I didn't feel like I've been using the sorted thing. Like this, if I get the original sequence out, right, and then with the remaining, is it possible if we only have fewer than 3? So we probably can. Hold on. What if I have 2, 3, and 5? This one won't work. Because eventually everything has to go, right? Which means each value must be in a sequence. So that means either a value is by itself, or the values, so it's either, I said, or we have overlap, right? That's the only two situations. We either have overlap or we have something by itself. But regardless, once we go through the thing, yeah, like 1, 2, 3, 2, 3, 4. And if we get 1, 2, 3, 4, then we have 2, 3 left, right? So that's the thing I was talking about. Like we have 2, 3, and then we need to know, okay, 2, 3 can be assigned to 4. And we can have many overlaps. Or maybe we can ask if the number exists in it. Okay, how do we ask? If a value appears only once, then we require if it has to the left and to the right exists. It can exist more than once, right? And then it's not going to work. Like 1, 1, 2, 3, 3. It's not going to work. So it has to overlap. How do I know? Overlap. So we get 1, we get 2, then we got another 2, so we know there is an overlap. Then we got 3, we got another 3, then we know it's overlap. Then we got 4. How do we know this 4 needs to go to the bottom? It's like, let's say range, right? You merge the range together. Now we want to demerge to get them back. Right now, I have no idea. I have no idea whatsoever. Well, things to be overlapped. How do we know? Well, if it's by itself, right? If we have something by itself, and then that's it. But if we have doubled it, right? We have something that's overlapped. That means that doubled one must be the start. The first double must be the start of the first one, right? So we can mark it. So we go, go, go. Once we hit the first one, then yeah, if we start with 1, then we just keep going, keep going. If we go to 2, we can keep going. If it goes higher, we can keep going. But if it goes lower, then we stop. Because as we take those away, it is okay. They can still keep going on. But if I snatch one that's lower, then we're resisting. Not resisting, we're making it harder for the other one. So we just keep going until the number of counts drops. So in the first example, we can go 1, 2, 3. That's fine because 3 has 2. So if 4 has 2, we can keep going. If 5 has 2, we can keep going, right? But if any of them drop down to 1, then we cannot go. Because if we take it, then we're taking away the opportunity for the doubled, right? For the doubled. They might need it. And then for me, I probably don't need it. Because if I also need it, that means I only have 2, right? So I'd say if I need it, but if I do it, then the things overlapped with me, they don't have it. So if I cannot make it, the overlapped cannot make it either. So it's going to fail no matter what. But if I have 2, right, overlap has 2, and I have 1, and I take it, and the overlap is dying. If I have 2 and overlap has 1, overlap is dying. If overlap has 3, then I'll have 3 as well. So this is my reasoning, right? No matter what, if I'm starting going, I'm the bottom layer, then the bottom layer will definitely extend more to the left or equal compared to the top layer. So whenever there's not enough for the top layer, the bottom layers stop because it cannot advance because the top layer is always smaller or equal to the bottom layer. So with that in mind, let's try to code this up. Yeah, I really don't think I'm using the other condition that they're non-decreasing. I'm gonna counter it anyway, and then there's only 2,000 values, so it's fine. So when I say counter equals, we got this, right? Then what do? We are going to get the array. When I say while counter, I don't know, while counter, sequence equals sorted counter. I just sort it. And then for s in sequence, when do you get the L, right? For s in sequence, L plus equal 1. If counter, let's decrement first. So counter s minus equal 1. And we say if counter s, if not, then counter dot pop s and L plus equal 1. Okay, no, we need to escape first. So how do we escape? For s in sequence, right? Whew. So everybody has at least something. So we go to this, and go to the next one. If this one is, it has to be larger than, right? So if it's smaller than, like, because when I visit out, I'll pop it. So the next one will be 1. That's going to be larger than this. And then if the next one is 2, I take from 1, so it's 1. So the next one must be larger. If the next one is 1, then it's a null point, right? Therefore, we're going to say if the next one, and enumerate. I'm going to check the previous one. So we say if counter s is larger than counter sequence I minus 1. So if I is larger than 0 and this or, right? If this or current is larger than the previous one, the current minus equal 1. And if it's not, then we're going to pop it, and L plus equal 1. Else, which is I larger than 0, but this doesn't matter, then we're going to break, which just means the current one can now be included. Then we break out, right? Now we break out. Now when we break out, we say if L is smaller than 3, then we return false. Otherwise, we go back to the top. Do it again, and once we're done, we're going to say return true. Okay? Let's give this a shot. It'll be on because each value will be visited exactly once. It'll be popped once. This is true. This is also true. This is false. Okay, at least these passed. Do we dare? Let's run some tests. I don't know. Just throw something at it. What else can we throw at it? I'm gonna throw some test case I found earlier. Right, we have 1, 1, 2, 3, 3. That's 1. 1, 2, 3, 4. 2, 3, 4. Oh, it's not gonna be like this. 2, 2, 3, 3, 4, 4. What else? What else did we figure out? Isn't that 1, 2, 2, 3, 3, 4? Oh, yes, this one should be true because we 1, 2, 3 and 2, 3, 4. Okay. Okay, try it. It's a new problem. Oh, wrong answer. Shoot. Okay, wrong answer number 1. Expected false. 1, 2, 3. Oh my God, I forgot to check. So if this or this, if this or this, I should be a and, right? And s minus sequence I minus 1 is equal to 1. Then we do. Yeah, I forgot about the requirements. It has to be exactly larger than 1. That was my bad. Forgot about it. Then my code is actually works for any situation. No, it doesn't work. It has to be strictly. Okay, let's try it again. It passed. Okay, 777. Interesting day. Well, it's not really good performance, but we got it. As we have this, right? I mean, we can. What if we don't sort? This will be enumerate counter. Oh, we changed the size. How about our keys? Can do it. What if we just say, I don't know, keys sequence equals a list of counter dot keys. We don't sort. Yeah, it made me believe that maybe this one will be faster if we don't sort. Go through everything, come out. Let's try this. If we don't sort, kind of let the counter to keep the original sequence. There we go. Sorting is the culprit. So we don't have to because the dictionary kept its order. Yeah, this is all in. 659. We use counter and the fact that counter keeps the insertion order. Since nums is already sorted, counters keys are sorted as well. We try to extend a sequence, subsequence, as much as possible until the count of the next value cannot support, right? Cannot support next value drops below the count of the current value. And we know we cannot extend anymore because we will be depleting the supply of numbers for the next traversal, the next run, the next subsequence. Keep track of the length, right, of the current subsequence. If any of them is smaller than 3, we return false. Otherwise, we finish going through all numbers in counter and return true. The one thing to note is that we also require consecutive values in the subsequence differ by 1. I forgot about it and got a wrong answer initially. All right, let's see the discussion. Yeah, it's a good problem. Greedy. This is greedy. $524. How much do I get? 700. Let's see. 524. Okay, only running once. So I have a frequency. We get a frequency. The next number requirement by subsequence. All occurrence of numbers already taken. Okay. Otherwise, need and larger than 0 n can be part of some and this one minus and minus, this one minus minus. Next requirement number is now n plus 1. Aleph frequency is larger than 0. A need, if this one is in need, then I'll take it. This frequency take it. Then next one will need. So we have a need. Else if frequency. So the next 3. Alright, if the next 3 is all good, we'll take it. And the next number needed. Else we have, so hold on, let me think again. So what we're saying is either we don't have any need, right? Then if the need is 0, well, yeah, then the next won't have another need. Then we simply go through the next 3. And the next number needed is n plus 3 as needed. So we try to extend as much as we can. And if it's needed, then I'll just take it and put the next one. If anything that's needed, the frequency is 0. What if I have a number we need? Right, we have a number that we need, okay, we increment, but that number doesn't exist. Oh, hold on, for any nums, we're following the nums. So if a number comes in, it is not being needed. If a number is not needed, then we'll create a subsequence. If a number is not needed, we say it must be the beginning, right? If a number is not needed, it must be the beginning. And then we'll get x2. No subsequence, so a number either is needed by a subsequence or it is not. If it's needed by a subsequence, then we just fulfill that subsequence. That's it. But what if you can start a new subsequence? You just don't know. Yeah, that's my issue. What if I have a lot Oh, because it's n. I constantly thought they're in a counter as well. No, they just do a frequency, and then they go with the numbers, right? So for each number, yes, we are occurring many times. We do go through them one by one. So we said a number is either being needed by someone, okay? That number is being needed, or that number is not being needed. If a number is not being needed, then we just fulfill the need, right? And we say if it's being needed, the next one should also be needed. Okay? Say the next one also be needed. That makes sense. Whether you fulfill or not, that's a different question. But what if your frequency drops? Well, if the frequency drops, then it just drops. It's fine. So, but initially, right? Initially, we have 3. Because initially everything is 0. The needs is 0. So we got 3. And we'll do this, otherwise return false. If all of them satisfies with minus, we say the next one is needed, right? Then we go to the next one. And the next one, if it's 0, then we skip, then we go there. If it's not 0, then it's not needed. Then we'll try again. From this, we'll go, and then someone else will get needed, right? And the need will not get, okay, this one works. Yeah, they all follow the same. Add to the existing subsequence. Or create a new subsequence. It's better than this, because this one I'm relying on this. Existing subsequence. This is subsequence I minus 1. Now I like the idea of need. That one is better. And for me, that one explains better. Okay, let's try this one. To record how many times a number is needed to form a subsequence. Now each number in nums is in one of 2 states. Either it is not needed by anyone, by any other subsequence, so it has to start its own subsequence of length at least 3, or it is needed by other subsequence. Then we fulfill the needs. If neither of the situations is satisfied, and the number is in a limbo state, which means we shall return false. Okay. Frequency. Okay, frequency is use counter. And need, we can use a default dict of int. Right. And we say for any nums, right? If need n is larger than 0, then so if freq n is equal to 0, then we continue. Right, this one we just use it up. Then frequency n minus equal 1, and actually this can be counter as well. This can be a counter as well. So frequency minus equal 1, need n minus equal 1, right? And then need n minus n plus 1 plus equal 1. Aleph, so need n is not larger than 0. Then n is to start. Then we say frequency n is larger than 0. Of course, because I already checked. If it's a 0, continue. Then we just need to check n plus 1. And frequency plus 2 is larger than 0. Both true. Then we say frequency n minus equal 1, frequency plus 1 minus equal 1, and frequency plus 2 minus equal 1. So they all minus equal 1. And need n plus 3 plus equal 1. Extend as much as possible. It's okay that if we cannot fulfill, the frequency just, if we have a frequency, right? And then we definitely can do this. Else, return false, return true at the end. So this is solution 2. Yeah. Hold on. It's the same. Okay, that'll be it for today. See you guys tomorrow. Adios.